Okay, good morning, folks. Glad to have you back. This morning's video is going to deal with a little bit different subject than what we've dealt with before as far as machining goes. Uh, this one is going to involve converting a power supply from an old computer to use as a workbench power supply, DC power supply. Possibly use it to control motors, DC motors for your table feed on your mill or on your lathe, for the well, for whatever use you might find for a DC motor in your shop. Various power supplies will come in different shapes, sizes. This one and this one is out of a Dell computer. This one happened to be out of a no-name one. What you're going to find, most likely, you will find the ATX style. The ATX style started in the late 90s. So unless you find a computer from the from the 80s or the early 90s, to pull one out of, you're probably going to find an ATX style. The easiest way to tell the difference in them, the old style, this is one of the oldest styles. It was just called AT, not ATX. The cables that hooked to the motherboard were a P8 and a P9 cable. There's two of them that connected like that. Now, the main difference in what we're going to discuss today and what we're going to look at is that these power supplies actually came with an on and off switch that mounted on the front of the case. All computers have an on and off switch somewhere, but these old style ATX had a switch built into the power supply. Chances are you're not going to find one of those. If you do find one of these, you can use this. You can skip over the part where I'll show you how to make an ATX on and off switch for it. So we're going to set this one back. This is out of a Dell. Nothing particular about it. You'll notice they've just got a mass of wires coming out of it. This in reality may be shaped just like this one, or the two different shapes may have the same power. We'll look at that in just a moment as well. One thing I want to say, besides the different shapes, is that if you don't have access to old computers and you have to buy one of these, they're going to be about $20 and up on eBay. But I highly encourage you, before you do that, go to your local recycler. I'm sure every town has one now where they take in old computers. And you're probably going to get one for, I'd say probably no more than $15. And you'll be able to look at it and be sure it's not, you can tell by the smell of it. If it smells like it's burned up, throw it back, tell them you want a different one. They will vary from country to country. The little switch on the back here, 110 or 115. In US you'll want it on 115 volts, and they vary from 50 hertz to 60 hertz. I'm not sure what European countries use as far as hertz is concerned. I think Canada is 50 hertz, but these power supplies are pretty much universal throughout the country. The one that I'm using here will have a connector in like this. Your country may have one a little bit different, or it may connect to the power supply the same way, but where it plugs into the wall will be different. Do not tell anybody that you saw on this video where I told you to take the cover off of it. It can hurt you. There's electricity in there, especially if you're dealing with the 220 side. Always have it unplugged. Everything we're doing here is going to be unplugged. I'm not going to show you taking the cover off because there's stuff in there that will hurt you. promise you it will hurt you if you have it plugged in and you get in there. So there's no need to take the cover off. You might want to dress it up a little bit, take the cover off, but that's up to you. I'm not going to tell you to take the cover off. One of the biggest things you want to look for or look on the power supplies is this little label right here. I'm going to turn the camera around right quick. Give you a close-up of the label. As I say, this one come out of a Dell computer. What we're primarily interested in for our workbench power supply is the plus 12 volts. And you want to be sure that the amperage, in this case this one has a 12 ounce max. Amperage is the amount of power that pushes that voltage along there, and amperage is drawn. You put a motor on that's, say, a 2 amp motor. When it's sitting there spinning with no load on it, it's going to pull approximately 2 amps. If you start to put load on it, maybe try to stop it by putting pressure on it, it's going to draw more amps than that. You want as high an amperage as you can find on the 12 volt side, if that's what you're going to be using it for. Now, if you see on this power supply, the plus 5 volts is 22 amps. But I'm not sure of much that you want to deal with for plus 5 volts. Plus 12 volts is what we're going to primarily, is all we're really going to talk about in this one. So be sure that's a high enough amperage on there. Now, if you find a power supply, let me hang that up there right quick. See this one? 12 volts, 2 amp. This is not worth your time. It's not worth your time to try to make it a bench top, a bench power supply. 2 amps, it's not enough to pull, excuse me, much more than a couple small light bulbs, something like that. This come out of a small desktop computer. I actually misread it when I took it out. I read the 15 amps up here, but that's on the 5 volts. So on the 12 volts, this was only 2 amps. Don't even bother, like I say, don't even bother with one that small. I'm going to say probably the least thing you'd want to pull out is one that was 5 volts. This old ATX one on the plus 12 was 6 amps. So that would be usable. The one we're dealing with here has the output of 12 amps on the 12 volt side. Now, to figure out how many motors, we'll say, that we can pull with this power supply, or what we can do with 12 amps, wattage is equal to the voltage times the amps. So we're dealing with 12 volts. The little motor I will be using in the follow-up video on this, which is actually a power seat motor out of a car. The power seats, as I say. It pulls 1.3 amps. So 12 times 1.3 is 15.6. The power supply we got here is a 200 watt output. 200 watt divided by 15.6. This power supply would run about 12.8 motors of those little motors at one time under minimal load. They're plenty sufficient. If you find one that's 150 watt, 200 watt, it should make you a good power supply. Now, see all these wires coming out of here? We got to do something with that, and we got to sort it out. So let me put you another graphic, if you will, up on the in front of the camera. All right. All the black wires, see if I can't make this a little. Alright, there we go. All the black wires coming out of the power supply are the common. Every one of them is the same thing. If you did pull the cover off the power supply and look, you'll see every one of them goes back to the same spot on the board in there. They are your common. In DC voltage, you have a common and a negative, which is what the black is. It's the ground or the common. The orange wires you see on there are the plus 3.3 volt DC. The red ones are the plus 5 volt DC. Yellow ones are the plus 12 volt DC. And the blue is the negative 12 volt DC. Now don't jump ahead and think that you can use the negative 12 volt DC to run your motor in reverse. The amperage on this one we're using right here on the negative 12 volts is only 1 amp. That wouldn't even pull the motor at a standstill. To reverse our DC motor, we're going to be using the yellow, the 12 volt DC, and to reverse that, all we do is change the polarity. What was hooked to the positive will now be hooked to the negative, and what was to the negative will be hooked to the positive. And that will reverse the direction of the motor. Alright. Let me come back around. Again, we got this massive wad of wires coming out of here. Red ones, we recall, are the plus 5. Black ones are the common. Yellow ones are the plus 12. I think there's one blue one in there. That's the negative 12 volts. We are not interested in that. There's a purple one that is a signaling. It doesn't carry voltage. It just signals off the motherboard. I think it probably has something to do with when the computer goes into a sleep mode. Several orange wires in there that are the 3 volt DC. The large connector, I showed you the connector on the AT case. What you will get will most likely look like this: a P1 connector. He has 20 pins on it. This is from an ATX case. Some of the very newest ones will have 24 pins, but the color codes are still the same. And if you notice on this, there will be one green wire. Of all the wires throughout this whole bundle coming out, there's one green wire. That's going to be our on and off switch. Find my little nippers here. What I'm going to do is clip that green wire right there at the connector and unthread it. Now, I could get any one of the black wires in this entire bundle. I need a black one to go with that green. I'm just going to, because they come out together, I'm going to get the one right next to it on the connector. Try to thread it back out so that they're coming out. These two wires right here, this black and this green, is going to be our on and off switch. We touch them together, it's going to come off. We remove them, it's going to be off. If you simply plugged in the power supply as it is right here, and the other end of my cord is plugged in, the fan is not turning. It's not doing anything. And hopefully, I don't know that you'll be able to see this. I put a little white paint on one of the fans on the motor in the power supply. I'm going to strip this off right quick. Black and the green. Alright, I touch them together and it comes on. And again, I don't know whether you can see that or not. But that is going to be our on and off switch. Unplug it again. Okay, should you connect your black and green together and the power supply does not come on and the way you tell is just simply look at the fan and see if the fan is turning. If you hook the black and green together and it doesn't come on, you got it plugged in, you know you got power, then that means you've got a power supply that has some type of, I'm not exactly sure what the reasoning behind it was, but that power supply requires a load before it will come on. This one I'm working on right here, sometimes I can plug it in, I could jump across to the black and green and it would come on, other times it wouldn't. So it's just some type of an energy savings that they did on some of these, some computers. Either way, the way to overcome that is to put a power resistor in. This power resistor, they're rated at 10 watts, 10 ohms. Now, you can get these at Radio Shack if you're lucky enough to still have a Radio Shack in your area. The closest one to me is about 30 miles. So, you know, we're talking about 45 minutes there, 45 minutes to get back, an hour and a half, 30 minutes there, 2 hours to go pick up something that's going to cost $1.50 probably. I think they're $2.50 for a pair at Radio Shack. So dollar and a quarter. So what I did was, of course, look on eBay. Let me turn back around here. This is the item number on eBay. I have no association whatsoever with this gentleman. I just found it, and it was exactly what I was looking for. 10 watt, 10 ohm. They come 2 in the package, $3.95, $2.90 shipping. So $6.85, but for me that was a whole lot cheaper than 2.5 hours driving to the Radio Shack close by. Now, what I had to do, and I've gone ahead and done it on this power supply, and it doesn't hurt to do this, even if your fan comes on. That just means it's going to put a little bit of a load on there. All I did was take one of these power resistors and zip tied it down, and then I hooked a black wire to it. I just picked one of my black wires out, hooked it up to the lead, soldered it on, put a piece of shrink tube on there so it doesn't short out. Red wire, remember, red wire is the plus 5 volts. Do not put 12 volts across this. It'll get hot enough to burn you, and may even get hot enough to burn itself out. But just put 5 volts across that, and your power supply always has a load at that time. All right, I'm going to show you a little. This is just a little power panel I made up ahead of time, or a little control panel that I'm going to mount on the side of the power supply. That's got an on and off switch, a power light, and a terminal strip. I'm going to turn the camera off for just a second and go ahead and mount this. All this was a piece of sheet metal that 2 inches wide. This power supply happens to be 6 inches long. To mount it, I took 2 of the factory screws out, being certain there was nothing underneath it. Drilled and tapped them out for 832 so that this could simply mount right up there. Alright, I'm going to turn the camera off, mount that on, and hook up the switch and the light, and be right back in just a second. Alright, now I have the on and off switch. I have my little panel mounted onto the side of the power supply, and I have the green wire and one of the black wires coming to the on and off switch. The reason I did this with the camera off was what happened was exactly what I was afraid was going to happen. These little bitty micro switches here, when you go pick up your supply, unless you're a whole lot steadier hand than I am soldering, you might want to pick up 2 or 3 of these, because I got the terminal too hot and I actually melted one of them and it came all to pieces. So got that back together now. I had a bag of these. So now I'm going to hook up a power light, pilot light, if you will, just a power indication light, okay, to give an indication when the power is on. For that, this is a 12 volt light. Remember, yellow was a 12 volt, so I'll pull a yellow and a black wire to this light. Okay, now I have my power indication light wired up so I can easily see from a distance before I get ready to leave the shop in the evenings or whenever. Power's on, walk over and switch it off. Now, the two wires coming out your light and the two wires out of the switch, it makes no difference the polarity on them. Remember, I'm using a 12 volt light, so I have a yellow and a black coming to it. You might pick up an LED at the Radio Shack electronics shop, wherever, that is a 3 volt or a 5 volt. There are a lot of the Christmas tree lights that are 6 volt, and some of them are 4 volt. They would work perfectly fine in there if it's a 4 volt bulb. Hook to 3 volt. How do you tell? Start out with the 3 volt, which was the orange wire, an orange and black. If it doesn't burn bright enough, try a red wire, which is the 5 volts, red and black. See if it looks like, you don't want to overblow it, putting 12 volts on a 3 volt bulb, but you can tell by the intensity when you hook it up. The switch makes no difference which one of the green or the black goes to the poles on the switch. I like to have it just like light switches in the house, where up is on and down is off. Now I'm going to wire this little terminal strip down here, and the way I'm going to wire mine for a bench power supply, I'm going to have two negatives to the commons, which is a black wire. I'm going to have two of them for 12 volt, which again is the yellow wire, and then I'm going to have one 5 volt and one 3 volt. So I'll have a power supply, a workbench power supply that I can tap into and pick up any one. Remember that the black is common, so I could hook three wires into one of these if I wanted to, or I'm going to have two here, so I could have a 12 volt one and a 3 volt one hooked to the same common. That doesn't matter. The common doesn't matter. It's your 5 volt, 12 volt, 5 volt, or 3 volt that makes a difference on the polarity. So I'm going to wire those. Be back in just a second. So this is going to be a workbench power supply. If I want to test 12 volt, okay, what's 12 volt? Maybe the radio in my boat's not working. Is it wiring in the boat, or is it radio? I can bring that radio into my shop right here on my workbench. It's 12 volts, so go between either one of the yellows and the black, being obviously keeping polarity correct. If I got a 5 volt device I want to test, go between the red and either one of the blacks. A 3 volt device between the orange and one of the black. Now I'm going to clean this up and clean up this bundle of wires right here and be right back. Alright guys, I think it's complete now. You see what I did over here? I just snipped off all these extra wires, bundled black ones together, red ones together, orange ones together, whatever. Put a little shrink wrap over them, tighten it down on there. I may possibly go back sometime, take the cover off, and snip these a little closer down right at the circuit board in there. But you haven't seen me do it, and I haven't told you to do it. So just be safe, guys. If you take this cover off and it's plugged in, not only does it take a chance of terminating you, but it's going to hurt while it happens. 110 volts is probably going to make you hurt yourself more so than it's going to hurt you. 220 maybe knock you off, but just don't mess with it plugged in. Unplug it. So what we have is a power supply now. We can turn on and off. We can see when it's on. We've got power. Quick little recap. Your power switch on and off is a green, the one green wire in the whole bundle of wires that's out there. The green wire, one green wire, and one black wire is your power on and off switch. Whatever the voltage of your power indicator light, whether it's 12, which would be the most common, 12, 5, or 3, that and one of the black wires hooked together. Power resistor is, again, any one of the black wires and the red 5 volt, so that there's a load on there at all times. And then the rest of it is up to you. What do you want to use this power supply for? You may only want to run one 12 volt device, so you take any black wire and any yellow wire and run that to your device and clip the rest of them off. Just be sure where you clip them off that they're isolated, that they can't short back together. On this one, I've made a simple little bracket put on there to hang it on the workbench or hang it wherever I need it. And I've got my 12 volt power supply, or I've got my multi-voltage DC power supply. I'm going to follow this video up with a video on a motor control, 12 volt DC motor control, and motors to use on your little hobbies around the shop or devices you might need in the shop. Have a good day, guys. Hope this was a help to you.